Lesson 5.5, Inequalities in two triangles. Inequalities in two triangles. We're going to use the hinge theorem to compare side lengths. We're also going to use the converse of the hinge theorem to compare angle measures. Hinge theorem and converse of the hinge theorem. If two sides of a triangle are congruent to two sides of another triangle, and the included angle of the first triangle is larger than the included angle of the second triangle, then the side opposite the angle of the first triangle is larger than the side opposite the angle of the second triangle. So if measure of angle A is greater than measure of angle D, then length of segment BC is greater than length of segment EF. Let's do the converse. If two sides of a triangle are congruent to two sides of another triangle, and the side opposite the included angle of the first is longer or larger than the side opposite the included angle of the second triangle, then the included angle of the first triangle is greater than the included angle of the second triangle. So if length of segment BC is greater than length of segment EF, then measure of angle A is greater than measure of angle D. Let's use this. We need two pairs of congruent sides. So we have 9's congruent and 15's congruent. We have the angles in between those. 79 is larger than 74, so the side opposite is larger than the one opposite the 74-degree angle. So there we go. Length of segment KL is greater than length of segment PM. Two sides 24, and we have our shared side, and we have the angles that are included between the sides. That angle 59 is smaller than 65. So the side opposite the 65 is larger than the side opposite the 59. So length of segment AD is less than length of segment BC. Two sides with 3, and we have a shared side. We have the included angle on the triangle towards the left, but we don't on the one towards the right. But we know all three angles of a triangle add up to 180. So if we take away the 93 and the 32, we get 55. That's the included angle. So now we're looking at the angles or the sides opposite those angles. So 53 is a smaller angle, so it has a shorter side. 55 is a bigger angle, so it has a larger side. And we have WX first, so that's going to be less than. These two angles, well, we have the shared side there. We have one included angle. Angle SRP is 83 degrees. But the two angles there form a linear pair, which means they're supplementary. So if we take the 83 away from the 180, we get 97. Now we can compare the included angles. 97's bigger, so that side's longer. 83 degrees is smaller, so that side's shorter. And we have length of segment PQ first, which is going to be greater than length of segment PS. Number 5, now we're dealing with all sides. So we need our two congruent pairs. As I said in class, the pencils and the pens. And we have the other side. And 35 is longer than 33. So the angle opposite, the shorter one, is smaller than the angle opposite the larger one. And D is the one that's first, so we're going to have greater than. We have the sides already marked that are congruent to each other. 18 shorter than 18.5, barely, but it is. So angle A is opposite the shorter, so it's smaller. And angle E is opposite the longer one, so that is bigger. So filling in the blank, we fill it in with less than. Measure of angle A is less than measure of angle E. Let's see, 2/17 shared side. Side opposite S is 13. Side opposite Q is 14. Now you can't really use a two or a one single letter name on that. That's the angle. It's actually RSQ. And they use the three-letter name as they should in the question up above. 14's longer, so this angle is bigger. So the angle that we have listed first is the smaller one, so that's less than. Next one, shared side. So we have our two pairs of congruent sides. 27 shorter than 28, barely. So the opposite angle to the 27 is going to be smaller than the angle opposite that 28. We need a three-letter name, and JMK is first, and that would be the one with the smaller, so that is going to be less than. That is the conclusion of Lesson 5.5, Inequalities in Two Triangles.